Hello guys, welcome back to mathematics. Today we are going to learn about significant figures. So what are significant figures? So they are the digits that contributes to precision of a quantity. Understanding precision like how close we can get to an actual value. Typically in an amount, if we have more and more decimals, that would mean more precision, but those decimals should come from a measure, for example. They cannot be the result of a division because sometimes we could get infinity decimals and they are not actually precision, they are just result of a division. But if we talk about a measure done by an instrument, more decimals would mean more precision. We also have that the significant figures start from the first non-zero digit. This is going to allow us to identify in a number what are actually the significant figures. So the first digit that is a non-zero, it starts with the significant figures and it goes until the end. Let's see some examples. For these three numbers, the first non-zero digit is the 3. So after the 3, in this case, we have just two digits, 3 and 6. So we would say it has two significant figures. In this case, it's the same because before the decimal point, we have just zeros, so they are not significant. The significant are the 3 and the 6, so again, two digits. Same case as this one. These ones don't mean anything. The ones that we are going to take for significant figures is again the 3 and the 6, so two significant figures. Let's check these other examples when we have a 0 in the middle. So the first non-zero is still the 3. So this one is also a 0, but since it's after the first non-zero digit, this is also significant. So in this case, we will have three significant figures. In this case, we just take out these zeros on the left, and then these three digits are going to be significant. So three significant figures. In this case, these zeros on the left, they are not going to be significant, but these zeros are going to be significant because they go after the first non-zero digit. So we are going to have 1, 2, 3, 4, 5, and 6 significant figures. And finally, these ones that I think is the hardest to interpret because we have zeros at the end. So in this case, again, the 0.36, this one is not significant, so we have 1 and 2 significant figures. But in this case, it's different, 3.60. This 0, since it's after the non-zero digit, it is significant too. So it's 1, 2, and 3 significant figures. And let's check this last one, 3.600. And you would say, but these two amounts are exactly the same. Well, not exactly. Taking in account the amount, they are equivalent, but this one has more significant figures. It has a 0 at the end, more than the previous one, so it has 4 significant figures. So I could just add zeros and say that they are significant? Well, not exactly. It's because these zeros should have an origin. So we need to know about the origin of the data in order to know if they are actually significant or not. Let me give you an example that is going to help you to understand this. So let's say you are in the lab and you want to know the weight of a cube and you have two available scales. Then you go and put it in the first one. And the scale tells you 70 grams. That means that that weight could be actually between 79.5 and 70.5. And what the scale does is to round up to 70 because it doesn't show any more precision. So you actually don't know in what number between those two values the weight is going to be. Well, let's say that you have this second scale that it has more precision. So you take the object and put it inside. And now this scale shows you 70.000 grams. So you know that this is going to be between 79.995 or 70.005. So notice that you have more precision here. So in this case, telling 70 is not the same to tell 70.000 because that means that you have more precision here. So basically, guys, when you don't have more information about the number, take the zeros as significant figures when they are after the non-zero. But if you know that it's a result of a rounding, then they wouldn't be significant. Let's see some examples that they are going to help you to understand this better. So in this case, it says to round to two significant figures. In this case, notice that we have 1, 2, and 3 significant figures. So that means we need to cut it until here. So we would have just two significant figures. So it would be just 0.50, and then we check if we need to round up or round down. Since the next number is 9, then it goes up. Remember, it goes up from 5 to 9. So when we round it, it would be actually 0.58. Now we have two significant figures. Let's check this one. 1, 2, 3, and 4 significant figures. So we need to get rid of these two. So it's just going to have two significant figures. So it's going to be 0.040, and then we check. The next number is a 5, so it goes already to a 7. 0.047, and this one has just two significant figures. Let's check this one. This one has a 3 before the decimal point, so this is the first non-zero. So we would have 1, 2, 3, 4, and 5 significant figures. So we need to take away this 3, so we are just going to have 2. 3 point. The next number is a 5, so this one goes up to 8. 3.8. Guys, if you have doubts about how to round, you can go in the video that I let you in the description. That is going to explain you how to round whole and decimal numbers. Let's check this one. This one is a little different because they are not decimals, but it works exactly the same. So it has 1, 2, 3, and 4 significant figures. We need to get rid of these last two. So again, it would be 1. The next one is a 6, so this one goes to 4. But we cannot leave it just like that, 14, because that number would be very far away from the actual number. So we just need to fill with zeros. These zeros are not significant in this case, guys, because they come from a rounding. Now let's check this one. This one is similar. 1, 2, 3, 4, 5, and 6 significant figures. So we need to cut it until here. So just the two first one are going to be the significant. Let's see. 2, in this case the next one is 3, so it stays on 6. And we just fill with zeros. Now we have two significant figures. And last one, it has 1, 2, 3, and 4 significant figures. We need to take away these two. So it's going to be 0.50. We need to leave the 0 because it has two significant figures. If you put just 0.5, just the 5 is going to be significant. So you need to include the 0. So notice, guys, that basically when you have a number that is not a decimal and you have zeros at the end, you are not sure if they are significant or not. If you have no more information, take it as significant because you are not told if they come from a rounding or from an actual measure. But when they are zeros on the right after the decimal point, like in this case, you are sure that this is actually a significant figure. Okay guys, let's do a practice. This time is going to be a little bit different. I'm going to show you a number and 3 options. Try to identify what is the correct one. So for example, in this one, we need to round to 3 significant figures. What will be the correct answer? Exactly, this one. This one is incorrect because the next digit is 2. So this one should stay at 2. And this one is incorrect because remember, in this case, we would have 4 significant figures and we just need 3. How about this one? 9.7652 to 2 significant figures. And this is the correct answer, guys. This one is not correct because this one has 3 significant figures, 1, 2, 3. And this one also has 1, 2, and 3. So we shouldn't leave the 0. We need to take it away, so we are just going to have 2. This one to 2 significant figures. And the correct answer is this one. Since this is a 6, this one goes up to 6, so 36. So this one is not correct because of that. And this one had 2 significant figures too, but notice it changed the number completely. We had 3 in the position of the 10,000 and it changed it for the position of the ones. Doesn't make sense. We shouldn't change the place value of the digits. This one, we need to round it to 3 significant figures. And the correct one is this one. This one, it has just 2 and it asks for 3. And this one doesn't work because the 5 makes the next digit to add up to the 21. Okay, this is the last one. We need just one significant figure. And the correct answer is 30,000. Since they come from rounding, these zeros are not significant. The only one that is significant, it would be the 3. In these cases, we put 2 significant figures. This one is correct for 2 significant figures. This one is not, because from 0 it jumps up to 5. No, it's not possible. Okay guys, let me know in the comments how many of them you answered correctly. And that was all for this video. Don't forget to subscribe guys, book your own lessons with me if you want, and drop any questions you have, or if you want me to explain another topic, in the comments box. Bye bye guys, see you next time.